Introduction to lenses. Do you know that lenses are found in camera, photocopier, magnifying glass, and LCD projector? But how are lenses different from mirrors? Mirrors reflect light. There are two types of curved mirror, concave and convex. When parallel light rays strike a concave mirror, the reflected rays meet at a common point known as the real focus. When parallel light rays strike a convex mirror, the reflected rays are scattered. But when you extend the reflected rays behind the mirror, they will meet at a common point called the virtual focus. Lenses, on the other hand, refract light. There are two types of lens, double or biconcave and double or biconvex. When parallel light rays strike a double concave lens, the light rays refract towards the thicker part of the lens. That's why the refracted rays scatter or move away from each other, while a double convex lens allows light rays, parallel light rays, to refract towards the thicker part of the lens, which is the center. That's why they meet at a common point known as the real focus. In describing lenses, it is important that we know the difference between the focal point and the focal length. When parallel light rays strike a lens, specifically a double convex lens, the refracted rays refract or bend towards the thicker part of the lens, which is the center, and meet at a common point called the real focus. Focus is the point where the refracted rays meet. It is also called the focal point. Now, the distance between the lens and the focal point is called the focal length. Take note that the point behind the lens where the refracted rays meet is called the real focus and has a symbol capital letter F. Twice the focal length is where 2F is located. The point in front of the lens is called the virtual focus or F prime. Twice the focal length is the point called 2F prime. How does a convex lens produce an image? Suppose the candle on the left is the object. When light rays leave the object and travels parallel to the principal axis, it will be refracted towards the focal point. When the light coming from the object passes through the center of the lens, it will not be refracted, it will just travel in a straight line. When a light ray coming from the object passes through the virtual focus and enters the convex lens, it will be refracted parallel to the principal axis. The point where the three refracted rays meet is where the image is formed. Another ray diagram is demonstrated on the screen, where the object is located between the focal point and the lens. You will see that the different rays, ray 1, ray 2, and ray 3 produce this image, which is larger and upright. Double concave lens is also called diverging or negative lens. Diverging because when parallel light rays strike the lens, the refracted rays scatter. That's why it is called a diverging lens. And when you extend the refracted rays in front of the lens, they will meet at a common point called the virtual focus or the virtual focal point. The ray diagram for a concave lens is similar to a convex lens. The point behind the lens is called the real focus, or F. Twice the focal length is the point called 2F. In front of the lens, where the imaginary refracted rays meet, or the extension of the refracted rays meet, is called the virtual focus or virtual focal point, labeled F prime. Twice the focal length is where 2F prime is located. This is an example of a ray diagram for a diverging lens. Let us describe each ray in the ray diagram for a diverging or concave lens. Suppose we place an object on the left side of the lens. Ray 1, coming from the object, traveling in a straight line parallel to the principal axis, will be refracted towards the thicker side of the lens. When you extend the refracted rays, it will pass through the virtual focal point. Ray 2 will pass through the real focus and refracted parallel to the principal axis. When you extend the refracted rays in front of the lens, you will see that they meet, the refracted rays meet at a common point. Now, to verify if this is the point of intersection of the refracted rays, we use ray 3. Ray 3 is the light ray coming from the object, passing through the center of the lens, and it will not be refracted, it will travel in a straight line. The point where the three rays intersect is where the image is formed. That ends our introduction to lenses. Maraming salamat!